Chapter 9, question 10. I love questions like this. It says, write the equation of an exponential function that passes through the points 2, 48, and 5, 750. So this is not shifted up or down. So the x-axis, yeah, y equals 0. The x-axis is serving as an asymptote for this. So, kind of big picture, we understand that there's 2 points somewhere in the Cartesian coordinate plane, and I'm trying to find the curve that would hit both of those, right? And I'm going to start. There's 2 ways I can do this, and I probably will do. It's worth to look at both. So I'm going to consider a table of values, and on this table we've got our x values and we've got our y values, and I don't know what 0 produces or 1, but I do know that when I put in x as 2, it gives me the number 48. I don't know what 3 produces or 4 produces, but when I put in x as 5, it gives me the number 750. So this is just me taking the 2 points that I have, and they're close enough to each other that I decided to organize this information in a table. Now, the other thing that I know is that if I start with 48 and I multiply by my multiplier, right, there's 2 parameters we're looking for. In an equation of the form y equals a b to the x. We're looking for our 0th term, right? And I could underline this with red. We're looking for the value that goes here. And we're also looking for our multiplier, right? This value b that I continue to multiply by. So if I took 48 and multiplied by a b, I would be at my 3rd term, or the output when x is 3. If I multiplied by my multiplier again, I would be at where x is 4. And if I multiply by b again, I'd be where x is 5. So this insight lets me make this profound statement. If I take the number 48 and I multiply by b, right, 3 factors of b, if I multiply by b cubed, I get the number 750. Which is a great way to start here. So now I've got this thing, and I'm going to divide both sides by 48. So b to the 3rd is 750 over 48. I'm just writing that, right? I'm not even grabbing my calculator. I think it's just so nice to be free of arithmetic. I don't care about what that ratio is. I can figure it out when I need it. The next thing I'm going to do is I'm going to raise both sides of this to the 1/3 power. So on the left-hand side, if we think about this conceptually, if I take b to the 3rd and I raise that to the 1/3 power, we understand what happens when I raise a power to a power, right? I end up getting the value b, right? This is 3 times 1/3 is 1, so this just becomes b to the 1st. And on the other side, what do I get? Well, b is 750 over 48 and then raised to the 1/3 power. Now, of course, there's a lot of options we have for evaluating something like this. Scientific calculator online would be fine. I'm going to go ahead and use our TI-84. So if I bring the calculator over, this is crazy. It's transparent in the background. I don't know how that's happened. And let's go ahead and look at this quotient. So I'm just going to do open parenthesis. Open paren. I'll do 750 divided by 48, and then I will close the parentheses, and then I will raise this to the power of, and then I'm just going to use parentheses for this fraction also. 1, not times 3, 1 divided by 3. 1/3. So here you can see I've got 750 over 48 to the 1/3 power, and that gives me 2.5. And it's probably not necessary, but you know that I would be a fan of looking at that number as 5/2. So we've got that our multiplier is 2.5, which is 5/2, right? So we know b. Now, if we want to figure out what a is, right, all I have to do is instead of multiplying to move forward, I just have to divide by that once, twice, and it will give me my value of b. So let's take this number. What was it? It was 48. So I'm going to take 48, and I'm going to divide by 2.5. That is the first term. I can write it down if I want. This term is 19.2. 19.2. And if I divide by 2.5 again, I get 7.68. 7.68. So there we go. We've now got both of our parameters, right? We know our 0th term and we know our multiplier, so we can write down the equation. It should be y is equal to 7.68 times b, which is 2.5 raised to the xth power. Now, that's a nice assertion, right? But I would feel much more comfortable if I could check that out somehow. So I am going to come in and I'm going to try it for the two values that I started with. I'm going to make sure that when I put in 2 it works, and when I put in 5 that it works as well. So let's go ahead and take 7.68. No. 7.68 times 2.5. No, 2.5 to the 2nd power. And when I do that, I get 48. And then if I change that to the 5th power, let me just go grab that expression. And I'll just come up here and edit this to a 5. This should now say 750. Yeah, that's right. Okay, so that's one way to do this, right? To think about a table of values and to figure out the parameters, just kind of reasoning through it like that. But there's another technique we talked about at the end of chapter 8 that I think it would be a missed opportunity for us to not go through that, and that's to look at this as a system of equations. So I know that I've got 2 points, 248, and the other point is, 5 and 750. 5 and 750. So we're trying to come up with an equation in the form y equals ab to the x, right, that will go through those 2 points. And what I can do is I can write a system of equations that will allow me to solve for my 2 parameters, a and b. I don't know what a and b are, but I do have 2 instances of an x, y, and another x, y. So from this, I can get 2 equations. Here's the first equation, y, 48, that's from my first point, equals ab to the 2nd power. That's from the first point also. And my other equation is 750 equals ab to the 5th power. That's x from my second point. So if you look at this now, I now have a system of equations. I can't solve this with elimination because this isn't addition, subtraction. It's multiplication over on the right-hand side. So elimination is not an option. But I can do 2 different things. I could get a alone in the first equation, and I could substitute that in for a in the second equation, or I could get a alone in both equations, and then I could solve using the equal values method. And I think that's the tact I'm going to take. I'm going to get a alone in both equations, and then solve using the equal values method. So in the first equation, if I isolate a, right, I'm going to divide both sides by b squared. So this becomes 48 divided by b squared, and that equals a. And then the other equation, right, when I solve this for a, get a alone, it becomes 750 divided by b to the 5th power is a. So you can see now I have two different ways that I can represent a, right? A is 48 over b squared. A is 750 over b squared. So I'm going to use this equal values method, clearly because a is equal to itself. A is equal to a. I can write the first expression for a, 48 over b squared, is equal to the second expression for a, 750 divided by b to the 5th power. This is an excellent opportunity to use fraction busters, right? If I want, I could multiply both sides by b to the 5th. So there's only a single term on each side, but I'm pushing this b to the 5th across those terms. And when I do that, I'll just go ahead and write this. I get 48, and then there's the b to the 5th over b squared. And over here I get 750. Here's its b to the 5th over b to the fifth. Now, the reason why I selected b to the fifth is because it cleans it up and there's no longer fractions, right? Once I simplify this, the right-hand side is just going to become the number 750. And the left-hand side is going to become 48 times b to the third power. So I now can clearly see a clear path for me figuring out what b is, right? And it's basically what I just did on the other method. This ends up becoming b to the third equals 750 divided by 48. And we've seen this before. This is going to be b is equal to 750 divided by 48 to the 1/3 power. So, and then if I take this the last step, right, b is 5 halves or 2.5. So this might seem like a bit more work, and actually it does seem a little bit more. It's good exercise for sure. But as these 2 points get further and further away, this might be a better technique to use. It was pretty easy to do this because I only had to jump 3 steps to go from 48 to 750 BBB, but that might change. Yeah, that's what it is. It's what it is. I like it. You know what? Let me do the other one where I do the substitution. So this right here is equal to a. I can take that value of a and I can put it into the second equation. So this is going to become 750 equals, here's a, 48 over b squared times b to the fifth power. Oh, look at that. I've got b to the fifth power being multiplied by 48 over b squared, which is what? Well, 750 is still 750, but that becomes 48 times b to the third. You know, that looks clean. That's not bad. That's not a bad way to go. I like probably I like that better than the equal values method. But you can see the reason why I'm stopping here is because at this point they're exactly the same, and it seems like I did that in fewer steps. Anyways, at the end of the day, our answer was y is equal to 7.6 times 2.5 raised to the x power.